Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about rocket politics. So let's dive deep into it. So you have to understand, rocket is intimately linked with the biggest boomstick humans have ever built. So at this point in time, you may be tempted to think that it's nukes. While they are boom, but they do not have the good delivery mechanism, because you are only as good as your delivery mechanism. There is no point of detonating those puppies in your own backyard. So ICBMs became the biggest boomstick delivery. So in terms of power, they are the most powerful booms we have in human arsenal. At this point in time, there is nothing that even comes close to that. And it has an unfair advantage, meaning it's much cheaper to build 10,000 ICBMs than it is to build 20,000 interceptor that gives you a reasonable probability of survival. So it is like unfair advantage, and it's the biggest boom delivery device we have. So you can understand it is important. Now, when it was birthed into reality, well, this was the granddaddy of all. V2. V2 changed the game. It changed the game so drastically. The sole reason Germany did not destroy the whole planet was simply because the guy was kind of distracted with way too many wonder projects. If all the money, all the attention, all the skills were only focused on this, no, the world would have been different. So this changed the game. Now here's the deal. This showed the world that it does not matter how good your armies are. It does not matter how good your air force is. It does not matter how good your navy is. You do not have this puppy, you're dead. So fundamentally, it reached a point after V2, one must have it. Like, you must have it at all cost, no matter how poor your country are. Like, you could be freaking North Korea, you could be Iran, you could be like a Nepal, you could be Bhutan, but you will pay whatever price that is required of you in order to acquire this, meaning all things are justified. And here's the deal, what about the people who are building it? Here's the deal, all sins are forgiven, meaning you could be the worst individual walking, you could literally be responsible for some things that you're, even criminals would be like, whoa my man, whoa, that will be forgiven. So fundamentally speaking, all is forgiven. Like, you could literally have a one regime that was like prosecuting people from prosecuting people of a certain other religion. They will still allow that religion scientists to work, because that technology is that priceless, meaning all sins are forgiven. There is no limit for us, like, oh, you did this bad thing, so we'll not let you in a project. It's like, bro, we'll give you a red carpet for this. So fundamentally, you have to understand that's how important it is, technology is. And what about cost, money? All price are justified. Your public could be starving on the street, does not matter. Like, Pakistan used to say this dialogue after India got its nuke, where it's like, if we have to eat grass, we will, but we will get ICBMs. Same things. Nukes, in that scenario they were saying nukes, but you get the point. Nukes itself is not that valuable unless you have a rocket delivery mechanism. So, and same goes with nukes. North Korea had nukes quite early on, but delivery mechanism is the hard part. So they are still developing it. Like, their country does not have electricity, but they're still developing the goddamn ICBMs. That's the whole point. So every price is justified, and every single risk is worth it. Meaning, would you develop a space program that is sending people to the moon and is very risky, as in, like, it could literally poof, three astronaut, best of the best? Would you still do it? Answer is absolutely yes. And yes, it was done. That's a real life tragedy, but all prices are justified, all sins are forgiven, and all risks are worth it. That's how important it is. Many times people genuinely do not understand, like, from a nation who does not have this, they will do all of it. And it's that's the dark side of it. However, with all that being said, all that being done, ironically, it also allowed us the stairway to heaven. Now, what does that mean? That simply means, if you stretch humanity to certain point in future, you will always reach certain bottleneck. The bottleneck is planet itself. Now, you change your mental perspective. Right now we look at Earth as like final destination, but you change that perspective to Earth is just a cradle. We started here, does not mean we have to end here. You change that perspective from Earth is all there was, or all there would be, to, like, Earth was a starting point, and yes, it was our first try. Of course, we're not going to be perfect with it. We're going to make Earth 2, we're going to make Earth 3, we're going to make Earth 4, whatever have you. In those sort of scenario, space provides us infinite space. That's the biggest limitation on Earth, space. What is the space potential of space? Well, there is a lot of space in space. You do not have to worry about it. And what about energy? We fight over energy on Earth. In space, ain't nobody got time for that. So it's one of those things, like, If we actually go to space and actually start to utilize it, all our problems will be solved in long term, like thousands of years from now. So fundamentally, it was a big boomstick, but it did allow us a glimpse into the heaven. So big boomstick, all price is justified. So keep that in mind. So what about the cost? Well, here's the deal. Government will be forced to pay you. Meaning, if you are a country, and there is a private entity in that country that is building something as important as rocket, no matter how much you charge it, they will pay you. They'll just flat out pay you. They're like, just take it. They're like flat out. So you can stay, just so you can stay in the game, government will be willingly giving you blank check. Yeah, we hate this part, but has to be this way. Like, that's the dark reality of it. To give you a context, like, this is one thing that most people do not have understanding of, and they say, oh, moon mission never happened. It's like, oh, if America can land on the moon in 1969, why can't they do it now? It's like, do you know how much money that was spent? Now, problem is inflation makes that number does not sound as big as it was. So this is a very good graph. You can find it. It is from basically 1955-ish to 2015. Now you're like, it's why not 2024? But it's like, this is what I found that had all three data. What data number one? What percentage of federal budget was allocated? That's one vector. Another is nominal dollar, meaning how much dollar people are hearing in the news, like, oh, we are paying 500 million, we are paying 3 billion, we are paying 4 billion, nominal dollars. And then you have the real data of it. That is 2014 constant data. Again, this graph is from that point. So what does this mean? This simply means if you inflation adjust the dollars, this is how much you were paying in 1960s to get the Apollo mission happening. If you give it a better contrast, you have to understand the federal budget, they were paying upwards of 4.5% to get that puppy off the ground. 4.5%. Now, how big is that? Right now, they are running at 0.4. Let that sink in. That's how expensive it was. When I say people are willing to pay whatever price needed, that's why they were willing to pay. Cold War. People would pay whatever price is required. So if you do that dollar adjustment only, then it starts to make sense. Oh yeah, we used to pay a lot more. Now we are paying much little, like half, not even half. Like, it's actually around only 30% of what we used to pay. So realistically, that's why Apollo mission could not be just, oh, why didn't we just do it? It's just like, yeah, it's expensive. And there was the only one opponent that had the probability of succeeding, went poof. What's the point again now? It's like, yeah, and Neil deGrasse Tyson says it very wisely. It's like, if China can ever demonstrate the ability to actually put people on Mars, like genuinely, not just like, oh, we're gonna do this or no, it's like, no, we actually put it. Next day, budget will go, wabam, it will be done. Like, no questions asked, it will be done. Blank check, get it done now. So let that be very real with you. That whenever somebody is like analyzing SpaceX and all that, like what's its worth and all that, you have to understand from a national point of view, SpaceX is like, shut up, take money. Like, they won't even ask like how much money. It's like, shut up, take money. How much money you need, I don't care. Take money. Just stay in the game. And to give you a real world context of it, ULA was getting $1 billion. Let that sink in. $1 billion annually. Look at how many launches they did. Oh, by the way, that was just subsidy. They charged on top of it. So yeah, and if you ever wondered how the heck Elon Musk won against the government, that's the reason for it. Tony Bruno was not the CEO at that time. He was the CEO at that time. So that's how it happened. It's like, he was like, dude, you're giving this much, you put that subsidy into account, we can give you a much cheaper launch, and you are not even allowing us to compete. So he did fight the case, he did won the case, he did launch the system, and then Congress was like, yeah, we have to shut it up. We cannot just like leak money. $1 billion annually. Please Google how many years they got it. All the SpaceX money burning parties will look like, bro, take some few billion extra. ULA was getting that. Let that sink in. ULA was getting that, who did not even had a rocket of their own at that point in time. Now, that's the American, like, big money and all that jazz. Okay, awesome. Remove that. Ariane Group, that is a European Union. And it's like, smart people, educated people, German engineering and hula la la. Yeah, they are charging right now $380 million annually. They were charging a bit less, but now they are charging more. And they are literally blackmailing the government. It's like, yeah, you don't pay us, we will stop this useless rocket. Let that sink in. So when this is one thing that I am noticing many people are missing, is like, oh, Starship will never work. It does not matter. Oh, Starship is super expensive. It does not matter. If governments are willingly, knowingly, for decades, are willing to pay companies like ULA, they will look at SpaceX and it's like the impact it has is like, yeah, just take it and go. And it's wise to do, because who everybody else is copying right now? SpaceX. Where does every satellite goes? Indian satellites are going to SpaceX. Bangladeshi satellites are going to SpaceX. Russian satellites back in the days were going to SpaceX. Every Tom, Dick and Harry, all roads leads to SpaceX. Do you really think US government will ever allow that road to go away? Like from their point of view, they are running on chump change. SpaceX is oh, you burnt $3 billion to develop Starship? Bruh, that's 3 years, bruh. Take it and go. So let that be, and be mindful. Even Europeans are like, yeah, we have to swallow. I'm not joking. This is their words. We have to swallow Ariane group. I'm like, this Ariane 6 rocket, because this rocket is useless. Like before it even came to be, it's useless. And again, I'm not saying this. They are saying it. We have to swallow it. We have to, because developing a new rocket that is actually current gen, not from 1970, will take too long to do. That's their words, not mine. So be mindful. All costs are justified. So if anybody is like giving this context where like all SpaceX has to do is poof Elon Musk out of it, because his mouth has the biggest issue, not the rocket cost. Because what other companies did for billions of dollars was nothing. What SpaceX is doing is like groundbreaking. Whether you like it or not, again, it's like his mouth is the biggest problem. It's like, yeah, I'm going to do this in 4 years. Like, bro, it will take you 14 years. Oh, I'm going to do this in 1 month. It's like, he is the problem. Let that be very clear. His mouth is the problem. So all like US government has to do, hey, SpaceX, you do not want to go bankrupt, poof, Elon Musk out of it. And then they're like, shut up. So that's the issue. And this is the context which people have to understand. You will pay whatever price is needed. So do not be like, oh, Tesla could go bankrupt. Nobody cares about it. But SpaceX, US government will be like, shut up, take money. Take money, not even how much money, take money. And again, is justified at this point, because look at the output of ULA or this. So that's the cost part of it. Now we come to the good news. The good news is competition. Now, why competition is good news? Well, it's the best way of getting what we call getting shit done. You want your satellite in space, get competition. You want your astronaut in ISS, get competition. That's the only way of getting these things done. Now, here's the two benefit of it. Core benefit, which why every country wants to develop it, unless you are stupid, is that it keeps cost and corruption low. Now, here's the deal. Imagine you are a monopoly like a Boeing. You can charge whatever you want, because companies do not have the luxury to go into someone else. They're like, hey, Boeing is charging, we have to pay because there is no one else. So Boeing can do whatever they want. Corruption goes rampant. Now you have competition. What happens? You have first, second. Now first one can be like, hey, we are comfortable, we're going to take a little bit of money for ourselves, increase the corruption. But here's the deal. You increase the corruption, your speed slows down. The second starts to catch up. So your corruption has to have an inherent limit, otherwise it will fall behind the two. The moment that happens, your corruption will disappear, because again, there is no point of leeching off a company if there is no company. So, and second one will never do corruption. Again, corruption as in 100% to zero. That's how I'm talking about it. And you will always have some percent, but minimal corruption will allow you to catch up to it. And again, it's far more efficient to skim off the top rather than skimming at the bottom when it's like barely functional. So it keeps corruption under control. It does not make you no corruption never. It's like keeps it low, under control. The more competitions you have, the more everybody's like, hey, we actually have to perform, man. We actually have to get some stuff done. So it's a very good checks and balance. Like you do not have to do 10,000 laws, 10,000 this and all. Two people, go. Solves the problem on its own. Now, this is the most critical aspect. India is suffering from this, is that elimination of single point of failure, meaning right now India has PSLV, GSLV and whatever have you. All we have is ISRO actually. One company or corporation or whatever you want to call it, or government entity, they are making the rockets. So if Indian Armed Forces, it has a department known as DRDO. It's like our DARPA. So DRDO is like, hey, we want to put Navik satellites on top, basically in space, so we can have our own GPS and do not find a situation that we were in during Kargil war. Okay, awesome. They developed the technology, they got the funding and all that. But ISRO was so behind schedule that DRDO is like, what the hell I'm to do? And it's a national security system. You cannot just go to someone else. They are stuck. And again, same thing happened with America also. And that's why America is still working their ass off to make sure there is more than one competitor, more than one SpaceX. Is that when Space Shuttle was built, the aim was that it's going to have 2 launches per month. What they got was around, give or take, 2 launches a year. That's how bad it was. Their aim was it will be cheaper than Saturn V. It was same price as Saturn V. And from that point of view, Saturn V had much more capability. It launched one space station in one go. And compared to Shuttle, they had to do multiple missions. So it would have been far more cost effective, far more safer just to go with Saturn V. So it was a very bad failure. So America learned it the hard way that you should not have 1.0. Oh, if this goes away, we lose our wings. That's not an acceptable option. And that's why they're still trying their best to make sure Boeing's Starliner or Dreamliner, I keep forgetting, mixing both of them. Basically, Boeing's crew capsule actually works. They never want to fall back to that point where it's like if Dragon falls for any reason, they're done. They do not want that. Under no circumstances that is an acceptable option for them. So if you want your nation to be happy, stable, long term, I'm not talking 5 years or 10 years, I'm talking 25 years, 50 years. Basically, you can close your eye and sleep and wake up and still have an awesome nation. You must have this competition. The more competition is good. So long term success and business growth happens in that sort of scenario. Now be mindful, how many competitors? And this is a very interesting thing. It happens in everything. Back in the early days of 2G phones and 3G phones, we had a time where India had way too many mobile phone operators, way too many. Tata, Docomo, I don't even remember most of them. Aircell, way too many. But all of them poofed away eventually, and now we have only three major players, quote unquote. And that happens with almost every field. Like you, back in the days, you used to have hundreds of aircraft manufacturers, then that slowly compiled into few tens. Now there are only few left. So it's one of those things that it will happen in car industry, aircraft industry, rocket industry. You can have a lot of starters, but always whittle down to few good ones. So if you are at under 5, everything is great. If you are at 10, it's an unstable bubble kind of scenario. I'm talking about rocket launch provider, not what people put on top of it. That could be hundreds, but launch provider wise, 10 is like it starts to look, again, as of now, as I'm studying it, it looks unstable. So if you have a scenario where it's like, hey, we have lot of rocket options, that may not be a good idea. That does not mean it's inherently bad. That simply means over time, do not expect all of them company to survive. Do expect some of company to get married together, compile together, or whatever have you. So right now, what's the benefit of having Blue Origin? Here's the deal. Right now, US government has the luxury. They have two companies that can individually build high-tech engines. I have no idea why the heck normal rocket engines are called high-tech. It's simply because everybody else is stuck in 1970. So high-tech engine. What does those high-tech engine means? Methane and liquid oxygen engines. So there are two companies, Raptor and BE4 engines. So that's a very good thing from a US government point of view. That's like, we good, we are awesome. We got two people, two supply chains, and both gonna do cost compete. Meaning, under no circumstances, one can charge exponentially more. They're like, dude, we're gonna keep things under control. Then you have Rocket Lab. Again, they are slowly chipping away. They also have some unique options. You have some launch option. They are working on Neutron that should allow satellite launching without too much hassle. And again, he is also planning for something big. And here's the deal. I would never count out Jeff Bezos because this dude is scary how patient he is. Like, this dude can go through ex-wife and still retain power. A man of this caliber is not to be underestimated. This guy is calm. Every time he talks, he's like calm, thorough. And that scares me. This guy is like a bit dinka-chika. It's like it goes up and downs and all that. But this guy scares me. And then again, you have Dragon, you have SpaceX, which again, at this point in time, US government will do whatever they need to do in order to keep it alive. And they may not even have to because there is competition. So they will already auto on performance mode. Then there is Stock Space, which is from Bill Gates' point of view. Again, the company is trying to do something interesting. And if they pull it off, damn. And then you have, Dragonfly. Firefly. So Firefly is also trying something unique. So you already have 5 competitors. And again, some are more there, but I do expect 3 of them should survive. 4, that would be awesome. 5, whoa. 5 would be like, and why the heck Firefly is there? Well, Firefly is there because they have achieved, let that be very clear, achieved what DARPA wants is like a quick delivery. What does that mean? That simply means DARPA gives you a bot. This is a satellite, I want this in orbit. They clocked it. 24 hours. Let that sink in. Here's a box. It's in orbit in 24 hours. 24 hours. That's why. Again, US Army always wants to be in a situation where they're like, oh, China attacked Taiwan. Oh, China is trying this new jamming technology. Okay, we built a new satellite. Okay, we launched the satellite. Satellite is in position. Before the soldiers are overrun, they're like, we got you back, bro. Don't worry about it. That's what they want. They have a player. They have a player. They have a player. They have another player. They have an extra player. That's what you want. So competition is the best solution. You never want to be stuck in a position where it's like, oh, if they work, we good. If they do not work, we dead. You do not want that. Now, what we can expect in terms of rocket design? Well, in terms of rocket design, you have to understand Falcon 9 as of now, no matter how good it looks, you have to understand Falcon 9 was built when SpaceX was poor. Now, what does that mean? That simply means from SpaceX points of view, they had to make sure the rocket was small enough that it can go through normal roads. It could clear normal, what you call bridges and flyovers and all that jazz. So they had to keep the diameter very low. That's why it's so skinny. The Falcon 9 is way too skinny for rocket. It's like even they know it. And again, even with that limitation, they had to redesign that puppy 5 times, major redesigns, and they had hundreds of minor patches. So you have to understand, Falcon 9, while it's perfect, is garbage. It's one of those things. It's like, first iPhone, however good it was still garbage. Compare Apple 1 to Apple 15 right now. Same thing happens with rocket. So if you want a better rocket for tomorrow, you have to take Falcon 9 design philosophy and throw 90% away. Exactly how you have in Iron Man 1, where he takes the Mark 1 armor, it's like, starts fresh, same thing. So what we need? Well, we need 5 to 6 meter kind of rocket. This is the optimum rating for a medium heavy class rocket. Now, why 5 to 6 meter? Well, 5 is like, we have designed that 5 meter is more than good enough. 6 gives you more than ample room just in case, and anything more than that becomes too big of a hassle in order to manipulate. And if you can afford it, which again, SpaceX is now rich, that's why Starship is 5.8. So if you're rich, you 5.8. So 5 to 6 meter fat system will help you. Now here's which alloy. Now rockets mostly are generally made out of aluminum lithium alloy. I had the luxury of going to museum, basically aircraft museums and all that. They had a PSLV fairing. Now that fairing had the ISO grid and all that, but it was made out of a lithium aluminum alloy. Those puppies are expensive, meaning that puppies is so expensive it will bankrupt you. And you can look at that, like why ULA, even though they redesigned their whole rocket system and they're like, we are reducing cost, why the heck they are still so expensive? You look at what they do. They buy a very high quality aluminum alloy. Awesome. They put it in a mill. Awesome. They mill some stuff out. Awesome. Here's the deal. They threw away 90% of it. They literally buy a milled plate, milled as in like a plate out of a mill, and then they CNC it. They throw away 90% of it just so they can get the best ISO grid performance, the best weight to ratio. I'm like, yeah, all you are collecting is you are paying for the 100% of material, you are paying for removal of 90% of it, and the CNC machine that can do that, the place and all that, all of those are expensive, and then you're gonna roll it. Yeah, no, that's just too expensive. What is the cheaper option? Stainless steel. Go with stainless steel. Stock Space is also talking about that. It's like, yeah, we looked into carbon fiber, we looked into lithium aluminum alloy. Outcome is just, you're going to go bankrupt. So stainless steel, and that's another reason why this is stainless steel. If you can't afford it, there is no point. So stainless steel booster, like everything has to be made out of stainless steel. At the bigger diameter, it actually becomes far more cost effective, and given the fact that it is cryogenically stable, and far more contractors, providers and all that jazz that can take care of it. Even the welding part is super easy. That's sorted. Basically, yeah, you will give up a little bit of capacity in terms of basically storage and all that, payload and all that jazz, but it's worth it. Now, what about engine design? Well, right now you will notice that every Tom, Dick and Harry is going to CH4 and liquid oxygen. Why? Well, the higher the carbon you have, the more oomph you get. The biggest oomph in liquid engine was F1 engines. Those puppies were kerosene and liquid oxygen. As in, you take kerosene, you clean that puppy, it becomes JP1, jet propellant one. You take that puppy, you clean that puppy up, it becomes rocket propellant one. That was used. But now rocket propellant one is kerosene. It's very powerful because it has carbon. It gives you oomph. The more carbon you have, the more oomph, more thrust you get. Problem is that carbon does not travel fast, meaning the CO2 molecule does not travel very fast. It's a very heavy molecule. It does not travel fast. You want water, water is like, water is fast. How do you get water? You burn hydrogen. So on one end you have hydrogen that gives you maximum mileage, but it's very weak, meaning it will not get out of pad on its own unless you have like very brutal liquid hydrogen engines, which I have not seen yet. Most systems that use liquid hydrogen, they rely on solid boosters to get off the pad, and as in like SLS and Space Shuttle. And on the other end, you have RP1, which is like, bro, I got this. RP1 is like, bro, I got this. I'm going to take your rocket from low Earth orbit, basically a pad to low Earth orbit without any issue. So that's the awesome part, but it's not efficient enough, meaning how much delta V you get at the other end is not that good. And not to mention, RP1 is dirty, meaning it creates soot. Because of the high temperature and long chemical chains available, it makes even more long sooty chemicals. And those chemicals, they destroy things, meaning your engines requires, fundamentally, if you want to reuse that puppy, you will hate yourself. You will hate your past self that agreed to RP1. And again, SpaceX learned this the hard way. It's like, and they were the one who are reusing it. It's like the shiny new white rocket becomes black rocket. It's like, how the heck that color happened? Yeah, soot output. So you have to go with something that is not as sooty, which is the best option. Methane is only one carbon, 4. So carbon is there to give you the oomph, so you do not need solid booster, and hydrogen is there to give you velocity without causing too much hassle. And because of the simple atomic nature of it, there is no soot creation. It's clean. So, oh, and it's also cheaper. Why? LNG, my man. It's just LNG. We have LNG tankers. So super simple. Now, how do you ignite that? Well, as of now, all companies are moving to electrical ignition. Now, if you remember old SpaceX footage, you would have noticed that they always used to have a big green flash. What was that? Well, they went back to old school of SR-71. SR-71 is using a very weird JP8, if I'm not mistaken, or 7. There was some fancy fuel mixture which made it very stable, awesome, but it was almost impossible to ignite electrically. So they had to have TTAP going there to ignite it. That was the biggest limitation. SpaceX used the same system, because if you have kerosene, which was subcooled, you have liquid oxygen, which is cryo-cooled, you put them, all you're going to get is a frozen kerosene out the other end. So to ignite it, you need something that put chemical love into it. TTAP was the solution. Problem, now you have a third propellant that you have to worry about. You run out of TTAP, your engine will not reignite. So, and again, even main ignition, it's an extra step which you want to throw away. So electrical ignition, and thankfully electrical ignition works quite well with methane and liquid liquid oxygen. How? I do not know. It could be a spark plug system as used in space shuttle booster engines, I'm saying main engines, or it could be a microwave igniter if there is a way where you can have a resonance frequency for the hydrogen that is in the methane. I do not know precisely, but if that is achieved, is because people are saying there is no actual spark in SpaceX Raptor design. If they have that sort of microwave cavity system, damn, outside of your system you can ignite fuel in there. That's like, damn, meaning they no longer have to worry about reignition. They're like, bro, we send ignite, it ignites the damn thing. So that's how you get the engine and ignition part sorted. Then we come to the hydraulics. So you have to understand hydraulics. There is no hydraulics. All you have is a motor that pressurizes hydraulic fluid, or you have a tank that pressurizes using some other things. So basically you have too much hassle to do something very minimal, move the engines. So people realized, what if we take the hydraulic system, yeet it, and put electromechanical actuators. Now, early days, electrical motors were not powerful enough. Nowadays, they're like, bitch, please, we got this. Like right now, many companies sell you this, and there are already rockets that are using it. And that was the change that companies were noticing, that SpaceX went from Starship Mark II to Mark III. That was the change. Electrical actuator. Again, it's not a new thing. It's available. You can just buy it. Heck, even airlines industries are realizing that hydraulics is just not worth the mess. And we have the development of electronics, reliability, and all that jazz too. Don't have to worry about it. Heck, you could have bought this sort of part which are already in use in small scale in 2010. It was already done. So electrical actuator, you cannot have bulky hydraulics. No. Like look at the SCE, semi-cryogenic engine 200, that is made by ISRO. It has huge hydraulics. I'm like, yeah, tell me you are made out of 1970 without telling me that you are made out of 1970. So it has to have electrical actuators. Now, like, wouldn't that require batteries? You're gonna need battery for so many things that is you need. And by the way, hydraulics also require electrical systems for maintenance, like encoder reading and like feedback control and all that. So might as well put that. So it's a solved problem at this point. And development of high energy lithium chemistry, as in lithium iron phosphate, solves all the issue. Then you have, how the heck you're going to pressurize that puppy? Autogenous pressurization. Now this was a test puppy. We used it, sometimes we did not use it, but more or less we have to go to this, is because if you are making a huge rocket like 5 or 6 meter diameter, there is no way enough you can put enough helium on there. And again, helium is expensive and you do not want to touch helium in your rockets. Why? Helium is one of those things that is a rare resource, meaning its price is very sensitive, meaning you can have your first 100 rocket launches, nobody cares about it. Government will randomly notice that they no longer have helium. They're like, yeah, price goes up 10 times. You do not want that sort of vulnerability. And again, it's not a wise thing to waste. So Autogenous pressure, meaning you take, in case of methane, you take the methane, you heat that puppy up, and you dump it into the methane tank. It does not have contamination issue, which was an issue with helium. If you have helium gas bubble diffusing into your stuff, you have nitrogen diffusing, you do not have to worry about it. And liquid oxygen, same thing. You take liquid oxygen, heat it up, you have oxygen diffusing into liquid oxygen. You do not have to worry about it. It's good. Autogenous pressure, good. That was used in space shuttle, SLS, and all that jazz. You do not have to worry about it. And how are you going to flush it? Because again, every time you stop the engine, you need to flush it, and every time you restart the engine, you need to flush it. The cheapest gas available for it that has enough oomph to do it, and without having a severe risk of freezing on its own, is nitrogen. Now nitrogen is close, but it can be managed. It's like the margin is a bit tight, but doable. Nitrogen should be the only extra component that you are carrying from these things. And now you're like, why do you need nitrogen? You want reignition, you need to, when you turn off the system, you flush it, so there is no propellant that freezes or turns into a gas pocket in a worse place. You do not want that. You want to flush that puppy. You need it to flush it with something that is non-reactive. So helium is good for that, but again, it's expensive, and not to mention it comes with its own challenges. So you want to use nitrogen. Done. And there is minor risk of nitrogen freezing. That's why you may need to use very high pressure nitrogen or heated nitrogen. Again, there is a gap. There is a temperature delta gap. How much in it? But if you want buffer, that's why people want to go to helium. And helium does have the benefit. No matter what you do, it's not gonna turn into liquid and turn into basically what you call frozen state. It's very difficult. But again, nitrogen can be made to work into it, and because of the price gap, it kind of justifies that sort of R&D that you need to have reliability, absolute reliability. And it's a sorted system. You see nitrogen being used. So yeah, it's a bit worse, but more than good enough. Yes, doctor. Reusable fairings. Now, fairings are huge. And it's one of those things, unless you physically see it, you will be like, what's that? Is the cap. Once you see it, like, oh damn, this is a rock solid structure that is very light, put on top of a rocket to go through Mach transitions and have shockwaves going through it, and it's like, I got you, fam. No shockwave will go inside me. It's like, damn. It's a very strong, very robust, and then they just yeet it out of there. Now, thankfully, even though when this puppy is going, it's almost at orbital velocity, not quite precisely where you dump it, that's up to you, but it has the benefit of having huge surface area. Huge. Now, benefit of huge surface area is that you slow down very quickly, meaning this does not get too heated up. Even though it will have giant plasma glow around it, it will not heat up as much as you would think. That's why it was very easy to recover without heat shields. And SpaceShips figured it out. Now, early days, they were trying to use boat and catch it, and then they're like, yeah, that's useless. And then they close the boat. Now they have just letting it touch the salty waters, and they recover it from it. And it works. It freaking works. And you have to build a low-cost second stage. Now, is there a way to recycle second stage? Unfortunately, it only works with big things. Now, once you have a huge puppy like Starship, go with full second stage reusability. But if you want to do reusability in second stage on low-cost rockets, small rockets, unlikely. Only weird design I've seen is Talk Space that is trying something new, but let's see what happens. But as of now, if I have to bet, I'll bet more on low-cost second stage becoming popular rather than a second stage reusable for medium-sized rocket. Huge rocket, go YOLO. But medium rocket, let's see. So this is the rocket design essence, that every government, every country is going into this. And if the country and government is not pouring their money into getting this sort of things sorted, yeah, you're going to watch it turn to dust in front of you. So let's talk about the next stage of these things. Well, first development we have to do is basically let go of solid rocket boosters. It's good for missiles, it's not good for rocket. Just let that design go. Let 1980s go, when we could not develop actually high power liquid engines. And we have to go to two stages. Basically, you have kick stage and third stage development. Now, kick stages for small rocket, where they're like, we need a very small payload, but we need very high delta V. Kick stage. Rocket Lab have already figured it out. And then third stage. Many times people have wrongly assumed that Saturn V was a 3-stage rocket. No, Saturn V was a 2-stage rocket. Apollo mission required a third stage. So that's how it worked. And that's why Skylab was just a third stage that was made into a space station. So you have to understand, if you have third stage, even with lower oomph in the base stage, not oomph as in like a lower velocity that you're gonna have with SRBs, you can do far more amazing things. So these two are far better option. Now, like, why? Well, it does not require you to touch the booster. Booster is not a static structure, especially if you are attaching things to it, meaning it has to be either reinforced or it has to be redesigned in multiple iterations, where you're like, oh, for 2 system, we're gonna have this many straps. For 4, you have this many straps. And like, we can optimize it. It's like, why go through that much extra trouble? Why not just eat that part? Or because here's the deal. Can you mass produce rocket tanks? Absolutely, it's nothing dangerous. You can go ahead. Can you mass produce rocket engines? Liquid engines? Absolutely, go YOLO on it. Can you do the same thing with SRBs? Hell no. The amount of Raptor companies, basically SpaceX is making, if you ever try to make that SRBs, you have to be a missile ordnance company. It's very expensive, very dangerous, and not cost effective. Again, missiles are awesome for missile things, not for space. For space, you want things that have liquid, so you can turn them off, you can control them, you can guide them. So kick stages are very good options, and third stage if you really want to go far out. So these two options are far better because it does not touch the booster, which you have to recycle, and it does not have too much effect on the second stage. Again, you may design a interstage that allows your second stage to just remain exactly the same thing. If you want to do that, that can also be done. So that's the whole point. These two approaches are far more better compared to strapping things to it. Thou shall not strap things to it. Now, how do you do deep space mission? Well, this is a key lesson that European Union has learned, is that we need what we classify as long duration ion engines. What does long duration mean? Meaning you start this engine, you do not have to turn it off after a month. You want this engines to be working for years, 6 years. That's right now NASA's record. You may even need more than that, more oomph, more duration. And now then the question becomes, if you're actually going deep space, not inner solar system, deep space like Voyager, solar panel is not going to cut it. For that reason, you have to use either RTGs to provide power, or more fish wise, kilo power. Now kilo power has the benefit of actually having power. RTGs, you would be lucky to get 400 or 500 watts. Kilo power starts at 1 kilowatt to 10 kilowatt. That's the range, that's the throttle range. And yes, it does have throttleable output, so you can literally go full out on it. And again, what will that entail? That will entail you launch it into Earth orbit, and then injection orbit. You will do your best to do it in injection orbit. Once it's in injection orbit, you ignite the ion engine and you do Brachistochrone burn, meaning you go as fast as you can till the 50% full thrust, and then you reverse it, full thrust, slow down. Now what's the benefit of this? Well, it will increase your time compared to just going full out, but it will allow you to slow down by the time you're reaching your probe. So meaning, instead of having a flyby of Pluto after 10 years, what we're going to have is a 6-year journey to it, where we will reach and actually orbit that easily. It's a very small gravitational body, so you may not have the luxury of Tokyo drifting around it to reach its orbit, but you will have such a slow down, you may be able to just land. So that's why you want Brachistochrone trajectory. You go very fast, not as fast as possible, but fast enough to actually justify it, and slow enough where you can just, as you're getting close to it, you're still slowing down, you can use your instruments still to study it very thoroughly. You won't be like, oh, it's just a flyby, we spent years, and it's just like, no, you want I'm gonna study you properly. So that's how we're going to sort the long deep space mission issues. Then how the heck are we going to solve the economics of it? Well, we need to solve two things. First, quick launch to LEO, meaning low Earth orbit now. Can it be done? Yes. SpaceX is reaching almost a cadence where they can launch 2 Falcon 9s almost in a day. We are reaching that. We're almost touching it. Almost. That's what we want. Basically, you can launch this now. Like, what will you launch? Well, is the people basically cargo in one of them and booster in the other one. Basically, third stage that you attach rapid docking. Right now, docking is our weak link. Can we dock? Absolutely. But right now, dockings take time, meaning docking missions with ISS is slow. What we want, we sent it there, we sent, dock it, go now. So that way we can send heavy stuff to basically moon. We no longer have to worry about refueling. We do not have to worry about anything expensive, as long as you can do quick launch. Quick launch is already sorted, and given the fact that even small satellite companies have reached a point where they're like 24-hour to orbit, it should be viable to do 2 quick launch in succession. And once you have rapid docking, you can do things. Even with small rockets, you can do things. If you can dock same payload mass again, you can do things. Like, imagine it this way: you launched a very heavy satellite that is like super duper hyper powerful radio processing unit and all that jazz, but here's the, it's so big, it's so bulky, it does not have enough space left and payload mass left for solar panels. You're like, okay, just okay, you will do your best to put something there, minimal, just solar panels that are attached to the surface, so it has some communication, some guidance. And the second one, the big daddy ion engine thruster that's gonna attach to it, and now the ion engine can take it from, let's say, LEO to GEO, and now it has huge solar panels, huge radio communication. Now it would be much better satellite compared to if you have made a something small that fits inside, let's say, 9-ton payload capacity to low Earth geostationary. And again, if the iron engines is fast enough, you may be able to reach from low Earth orbit to actual geostationary orbit in weeks rather than months. And once you have that much mass in geostationary, damn. So these two things will allow us to do a lot of more things with current rocket fleet, as long as we can sort out rapid launch and rapid docking. Go there, dock ASAP. And LEO refueling is necessary if you want to touch Mars. Moon, we can go with a docking, but if you want to really go to Mars, we have to do refueling. And again, SpaceX is working on that, and there are other concepts from ULA also that is working on refueling. If this puppy and China is working on refueling, so let's be very clear. More than enough people have figured out that rocket equation likes refueling. Meaning, once you have something in orbit and let's say it's completely empty, you refuel it up. Hey, you are already at orbital velocity. Now you ignite your puppy. Lot of payload very far. So LEO referring for more payload to Mars. Basically, if you actually want to go to Mars and do things, this is compulsory requirement. Now let this be very clear. I'm very clear about SpaceX financial survivability, not Mars survivability. Why is that? Who is going to pay for it? Elon Musk is not that rich, and again, Tesla stocks are not that high. Again, as a rocket company, companies will be willing to pay you to develop rocket. Nobody is willing to pay you, okay, go and do missions on Mars. Maybe NASA, maybe 1 or 2 missions, but actual self-sustaining colony, that requires blank check, continuous blank check. That is something bit much even for national government's point of view. As like, really, do we spend like $10 billion annually just so we can develop a Mars? That's hard pill to swallow. Not impossible, but hard. And how do we make economics far more cost effective? Large private LEO space station. Thankfully, more and more people are jumping into this. So we have basically ISS that's slowly going to transition into axiom space, and then we're going to have orbital reef hopefully soon. So all things are leading to a point where we're going to have amazing things in upcoming 10 to 20 years, hopefully. So this was my presentation on rocket politics. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.